So, welcome to Mostly Engineering and another part in our Enigma Build series. So, welcome to this episode, and our 3 rotors are now finally finished, and that also means that we can finish our stepping mechanism. So, these parts over here, and in one of the last videos you saw it in 3D printing, but now we will do it in metal, put the springs in, and hopefully at the end have a working mechanism. Most of the parts are relatively straightforward machining. The interesting part will be the registration rollers. So here we have to machine a flexible silicone roller. Never done this before. And laser cutting unfortunately doesn't work, at least not in the thickness we need. And then this part over here that will require a little bit more elaborate CNC setup, and on top of this a little bit of manual machining. Alternative, we could do it completely manual, but I think this way is a little bit quicker and a little bit easier to do. So with no further ado, let's start exactly there. So, and here we have our part as it should be in the end, and this is the part we will actually machine. So you see we don't have the hole over here, we don't have the slit, and we have an overhang that is there, and when we overlay we see that we have to machine this away, and drill the hole, doing it manually because this is a point our CNC can't reach. And for the toolpath you see there's a rather lot going on. So first we plane the whole surface because the part is only 13 millimeters high, but the material that we have at hand is 15 millimeters, so we just plane 2 millimeters off the top, and then while the short and chubby end mill is still in, machine everything it can reach, because here the likelihood of breaking off are much lower. Then we switch to a 1 millimeter drill the hole for a wheel over here, and then finally switch to the long end mill that can reach all the way to the bottom and machine the rest with it. And yeah, that's basically it. So let's go over to the CNC and look at how it works. So, and here we have our machine parts, and I have to say I'm not that satisfied by how they look. They look quite rough around the edges, and machining part of it on the CNC with several tool changes, and then the manual machining is probably not the way to go, at least not in the setup I have here, because yeah, it looks rather ugly. So in the future I either do it completely manual or maybe in separate parts. Let's see. But for now, functionally that part will do, so we can put the mechanics together, see if everything works. And for this, this part is good enough. The other side came out actually quite nice, but as you see, it's a much simpler part to do. Really annoying with, I think, this alloy was that drilling this 1 millimeter holes for 5 holes, I actually needed 6 drill bits, and yeah, also part that was really frustrating. So, and with this done, let's do the rotor registration and the drive levels next. machining our silicone rubber works really nice. What I used here was a down cutter, so that the cutting forces push the material down rather than lifting it up. And with this going slow with lots of cooling, we got a really nice result. Only exception is when the part got loose on the last pass, and so we have a little bit rough around the edges, how you can see here. And what you can also see are the remnants of the laser test. And here we have to say that was original plan, but it doesn't work because I think the material extinguishes the flame, because we never cut deeper than 2.5 millimeters. Even if we put 4 times as much energy into it, we don't get deeper than this. So let's do the rest of the parts and then put everything together. So, and here we have the rotor registration lever, and it came out really nice. Of course, the plastic bearing over here is not due to the original, but doing it this way, we first saved material, so we didn't have to mill down all this material over here. And the main reason is being a glide bearing. It glides very nice, it moves very nice, and we don't have the risk of it binding over time, so it will run smooth for much longer. And with this small detail, it won't matter if you ask me. Then with the drive levers, we did exactly the same, so they came out really nice too. What we have to do now is replace all the 3D printed parts with the metal ones, see if everything fits, and adjust the parts accordingly. So let's go to the workbench and do exactly that. our stepping mechanism is finally finished, and not gonna lie, it was a fight. Each and every component put up a fight, and yeah, it was quite a struggle to finish it, but we did. That's the good news. The bad news is that it doesn't actually work. So if we push our seesaw down, you see the rotor moves a little bit, but this is about it. And yeah, that's quite a bummer, and not gonna lie. And the reasoning behind this is, I think, twofold. First problem is our seesaw. So our 3D printed material is a little bit flexible, and when you push the seesaw down, you feel how it's flexing. So rather than pushing the rotor up, it flexes out of the way. And to remedy this, my first try will be to reprint it in this material, what is a lot stiffer. And if this doesn't work, what unfortunately seems to be likely, we have to redo the seesaw in metal. And our other problem are these springs over here that tension our drive levers. So the ones we can buy always have a straight edge, but we need a 90-degree bend in it. So we have to do it ourselves, but bending spring fields at a precise angle at a precise position is actually exceedingly difficult. So they're all a little bit off, and this means our drive levers sit a little bit wonky, and tensioning them and positioning them is exceedingly difficult. So each individual drive lever has a different amount of tensioning, and the normal position is slightly off. So we have to redo this. What we have to do is either find a way to bend the springs precisely, or bite the bullet and order some custom springs. But all of this is for different episodes, because for now I'm absolutely done with it. And yeah, on this sad note, it's time to end the show. I hope you enjoyed it nonetheless. And if you have questions, comments, as always, let them down below, and I try to answer them as quickly and correctly as possible. Don't forget to like and subscribe. And all I have to say now is thanks for watching, and see you at the next time. Bye bye.